Hi, everyone. In this video, we're going to talk about the sum rule for probability. So before we actually state what this rule is, let's talk about what we've already discussed. So the product rule for probability, this tells us how to find and probabilities. And so by that, I mean probability of E and F. So this means it tells us how to find the probability that both events occur. And the way we did this is we looked at the probability of one of the events and we looked at the conditional probability of the other event and we multiplied them. And so that's why we call it the product rule. Now the sum rule, so this tells us how to find and, so the question is, how do we find or probabilities? So how do we solve something like the probability of E or F? So what we want is we want to find the probability not that both events occur, but that at least one of the events occurs. Okay, and so how do we do this? And so what we might be tempted is, so first thought, since the product rule just tells us to multiply, and this is called the sum rule, we might want P of E or F. I'll put a little question mark here because maybe it is, maybe it's not. P of E plus P of F. But as we'll see, this doesn't really work all the time. So this is not always true. And to see this, let's do a first example. So you roll a six-sided die. And my question is, what is the probability of rolling a multiple of 2 or a multiple of 3, or rolling a multiple of 3? Okay, and so to answer this, let's find what our events are. So E is roll a multiple of 2. F is roll a multiple of 3. And so what we're trying to find is what is the probability of E or F. So we're just rolling a six-sided die. And in this case, it's not hard to write out our sample space. 1, 2, 3, 4, 5, 6. And so if I color code what I'm doing a little bit, let's say blue is E. And so let's see, what is the subset that corresponds to E? So E is multiple of 2. And being a multiple of 2 is the same as being an even number. And so from S, the only numbers that are even are multiples of 2 are 2, 4, and 6. And so E is 2, 4, 6. Now I'll switch to green. F, well, so these are all the multiples of 3. 1 isn't a multiple of 3, 2 isn't a multiple of 3, but 3 is a multiple of 3. 4 and 5 are not multiples of 3, but 6 is. And so, oops, we've got 3 and 6 for F. But now we can also just directly say, what is the event or what is the subset that corresponds to E or F? And so for each, what we do is for each number, we go through and we ask, is this a multiple of 2 or a multiple of 3? So 1 is not a multiple of 2 and it's not a multiple of 3. So it's neither of these things. And so neither of these two. And so it doesn't go in our subset. 2 is a multiple of 2. So we include it. 3 is not a multiple of 2, but it is a multiple of 3. And so at least we don't need both to happen. We don't need both of these guys to be true. We just need at least one of them. And so 3 goes in our subset. So now 4 is a multiple of 2, so it goes in. 5 is neither. And 6 is a multiple of 2 and a multiple of 3. Well, both is fine, right? Both can be true. It can satisfy both of these two. It just can't satisfy neither. It can satisfy one, it can satisfy the other, or it could satisfy both, and that's fine. And so it satisfies both, so it goes in. Okay, so now we have the subsets for E, for F, and for E or F. So let's find, we can directly find the probability of E or F. And so this is the size of E or F divided by size of S. Well, how many things are in E or F? We've got 1, 2, 3, 4. There are 6 outcomes in S. And so the probability is 4 out of 6. Now let's see what happens if we just do P of E plus P of F. So that's going to be, well, so P of E, let's just compute one of these one at a time first. E has 1, 2, 3 outcomes in it. So P of E is 3 over 6. P of F, well, F has 2 outcomes in it. So the probability is 2 out of 6. And so now P of E plus P of F is equal to 3 out of 6 plus 2 out of 6, which is 5 out of 6. And we see 5 out of 6 is not equal to 4 out of 6, which is the probability of E or F. And so we can't just add probabilities. We can't just add probabilities for or. And so why? What's going wrong? What's going on? Well, so notice, if you look at these color codings, we counted 2 once, we counted 4 once, and we counted 6 once. We counted each of these once when we were looking at what to include for E. We counted 3 once and 6 once when we were looking at what to include for F. And so every single one of 2, 3, 4, we counted those once. But 6, we counted twice. We counted it once, included it once when we were looking for multiples of 2. And we counted it twice when we were looking for multiples of 3. So we counted 6 more than once. 6, we counted it twice instead of just once. Okay, because we're saying, oh, we're counting it once for E and once for F. But we only want to count it once. We don't want to overcount it. And so that tells us that we overcounted. But why did we overcount 6? Why did we overcount 6? Well, because we counted it once when we looked at E, and we counted it once when we looked at F. And so what this tells us, and we can directly see, 6 is a multiple of 2, and 6 is a multiple of 3. And so we counted it twice because we counted it once for multiple of 2, once for multiple of 3. So we overcounted 6 because 6 is a multiple of 2 and a multiple of 3. And so if we do, and so notice, let's say P of E and F. So what is the event that corresponds to E and F? Well, this is all of the E of F, E and F is just all the numbers that are multiples of 2 and 3. Well, going through our subset, 1 is not a multiple of 2 or 3, so that's out. 2 is a multiple of 2, but not a multiple of 3, so no 2. 3 is a multiple of 3, but not a multiple of 2, so it's not in and. 4 is a multiple of 2, but not a multiple of 3. 5 is a multiple of neither, and 6 is a multiple of both. And so the probability of E and F is equal to the size of E and F, which is just 1 because the only thing in it is 6, divided by the size of S, which is 6. And so notice our P of E plus P of F overcounted by 1/6. So P of E plus P of F minus 1/6 equals 4/6, right? Because this is 5/6 minus 1/6 is 4/6. And this is the same as P of E or F. And this 1/6 is the same as this 1/6. And so our sum rule is this. The probability of E or F is equal to the probability of E plus the probability of F minus the probability, I'll move this down here, minus the probability of E and, I'll do this lowercase, minus the probability of E and F. And so we need this minus P of E and F term to keep us from over counting. And the idea is like this. If you've ever seen a Venn diagram, we can sort of visualize it like that. And so let me switch to, say, blue. So maybe this is one event, this is E. And then for F, maybe we've got this here. This is F. And so when we count F, or when we count E, we've got everything in E. And this overlap region right here, this overlap region tells us, so this overlap region right here, this is all the stuff that's in both E and F. And so we count it once when we count E. And then when we count F, we look at everything in F. But now we're counting this twice. And so we're counting it once for everything that's in blue, and we're counting it another time for everything that's in green. But we don't want to count it twice, so we subtract everything that's in here because we have 2 of these guys. So we subtract 1 away, and that gives us our proper count. Now, here, I say that this is not always true. So when can we just add them? Okay, and so when can we just add probabilities? And so if we look at this rule, so P of E or F is equal to P of E plus P of F minus P of E and F. And so if this guy is 0, then we have our equality P of E or F equals P of E plus P of F. And so when can we add probabilities? Answer, only when P of E and F equals 0. But we have a special name for events like this. We call these mutually exclusive. And so that's the same thing as saying only when E and F are mutually exclusive. And in other words, the subsets associated to them have no overlap. Okay, and so this is the only time we can do this. But if E and F are not mutually exclusive, you must, I'm underlining it a bunch of times, and I'm putting stars around it. So please remember this. If E and F are not mutually exclusive, you must subtract P of E and F from the sum. Okay? And so this was just a brief little intro. In the next video, we'll see more examples of using this sum rule in action. I will say one quick comment. There, just like for the product rule, and for the multiplication rule and lots of other rules, so just like for the product rule, there is a version of the sum rule for more than 2 events. But we will not be discussing it further. We will not be going over it because it's longer and more complicated. And what I really want everyone to understand is it's just the regular sum rule for 2 events. I'm thinking that will probably be confusing enough as is. Okay, so that's going to be all for this video.